go look at problem number 12 first. Segment VR, VZ, and ZR are mid-segments of triangle UWY. Find the value of X. So, one of the first things that we can do is mark these two segments as being congruent. Because if these three segments, VZ, ZR, and VR are mid-segments, then V, Z, and R are midpoints. So UV and VY are congruent. UZ and ZW are congruent. RW and RY are congruent. One of the things that we learned about when we studied mid-segments of triangles is that the side that is parallel to the mid-segment is twice as big as the mid-segment itself. So therefore, if ZR is 25, then UV would also be 25, and VY would be 25, because this would be the same size. So UY equals 2 times ZR. UY has been represented by X. That would be 2 times 25. So X is 50. What else would you guys like to see? Number 14, absolutely. Problem number 14, determine what type of triangle the following side measures would make: acute, obtuse, or right. So when we were talking about this section, if c squared is greater than a squared plus b squared, then it is an obtuse triangle. If c squared is less than a squared plus b squared, then it is an acute triangle. And if c squared is equal to a squared plus b squared, then it is a right triangle. C has to be the biggest side. So when I'm looking up here at these sides, 13 has to be C. So we're going to do C squared. I don't know whether that's equal to, less than, or greater than. And then we're going to have a squared plus b squared. So we put 13 in the place of C. So I have 13 squared. 7 and 12 go in for A and B. Yep, we square both of those, and we add them together. All right, so now we calculate these. What is 13 squared? 169. 7 squared? 49. And 12 squared? 144. So then we need to add the 49 and 144 together. What do we get when we add those together? 193. On the other side, we had 169. Which way should the inequality go? Less than. So what kind of triangle is this? Acute triangle. All right, what else would you guys like to see? Number 13? 15. Number 15, absolutely. You're welcome. Find the value of X. We only have one side. We only know this side right here. Which side of the triangle is that 14? That's the hypotenuse. We know one side and we know one angle. We have this 43-degree angle. And we want to find another side. So we need to label up our sides. We have the hypotenuse already. What are the other two sides that we need to label up here? Yep, the adjacent and the opposite. Which one is the opposite side? What'd you say? We don't know which one is the opposite side. We should be able to tell. X is not the opposite side. X is touching the angle where we're standing, so it can't be opposite where we're standing. It's the other leg, the one that is totally blank. This is the opposite side. You have to go through the center of the triangle from the angle that you're standing at to get to the opposite side. So X would have to be the adjacent side. We want the adjacent side. We know the hypotenuse. We have no information about the opposite side at all. So when we do SOHCAHTOA, which side do we get rid of? Which side are we not going to be looking for at all? Opposite. So that gets rid of this one here. So, and it gets rid of this one. Yes, so it has to be cosine. So we do cosine of our angle. So cosine of 43 degrees is equal to what over what? X over 14, adjacent over hypotenuse. What do I do now if I want to solve this for X? What'd you say? Multiply both sides by 14. We want to get the X all by itself. So I'm looking on the side where X is and figuring out how to get that side alone. That side is only a fraction. So we're going to multiply by the denominator to get rid of the fraction. Cancels out my denominator. And then I have to go grab a calculator. Feel free to come and grab one. We do 14 times the cosine of 43 degrees. And what do we get? You did 14 times cosine of 43? Your phone calculator is using radians, not degrees. 10.238. Is equal to X. What else would you guys like to see from the packet? Yes. Number 9? Absolutely. Number 9, in the figure, JK is parallel to QR. By what rule is triangle JKZ similar to triangle QRZ? Remember, when it just has that single squiggle like that, that means similar. And types of similarity that we had angle-angle similarity. We had side-angle-side similarity. And we had side-side-side similarity. All right, so we know JK is parallel to QR. Since they are parallel, that means that I can draw what letter? Does anybody remember what letter we draw when we have those parallel lines? A Z. It helps me find what? What does a Z-type shape help me find? Alternate interior angles, so tucked into those corners. So angle J is congruent to angle Q. I could do my z going the other direction. I could do jk to kr to rq. There's another pair of angles up there that I see that are congruent. Does anybody see them? There's a pair of angles that I could have marked even without knowing that I had parallel lines. Well, 6 is the length of this side right here. I want to know which angles. Vertical angles, yes. Right here. Angle JZK and angle RZQ are congruent. Technically, so are angles K and R. So I can say that angle JZK is congruent to angle RZQ because they are vertical angles. Angle J is congruent to angle Q because they are alternate interior angles. So by angle-angle similarity, triangle JKZ is similar to triangle QRZ. Right. What else would you guys like to see? Number 11? Absolutely. Number 11 says if AB equals 6 and BC equals 4 and AE equals 9, find ED. All right, so AB is 6, BC is 4, AE is 9. It says find ED. Are you guys okay if I call ED X, since that's the thing that we're looking for? When I have these parallel lines right here in my triangle, this creates proportions. So I'm going to look at this side over here, and I'm going to make a proportion out of that, 6 over 4. We're going to set that equal to, and then I look at this side over here, and I create a proportion in the same way. Since I put 6 on top of the other proportion, what has to go on top of this one? Yes, 9 over x. And now we want to solve this for x. I have 2 fractions, so I'm going to have to do multiplication 2 times. Let's start off by multiplying both sides by x. It's going to cancel my denominator over there on the right. The x only multiplies to my numerator, so I have 6x over 4 equals 9. And then we multiply by our other denominator. We're going to multiply both sides by 4. And so then I get 6x equals what? 36. What do I do now? Divide both sides by 6. And that means x is what? X is 6. Thank you. All right, what else would you guys like to see? Number which one? 17, absolutely. Problem number 17. This is the next to last one that we have prepared for today. Use the triangle to the right to answer the following questions. Write an equation to find the value of theta, then find theta. Well, theta is right here. So this is where I'm going to stand. I need to label up my sides. Where's the hypotenuse? 18 is my hypotenuse. Which side is the opposite side? 12. And so x has to be which side? Adjacent. All right. We need an equation that we can solve to find theta. I know a number for the opposite side, and I know a number for the hypotenuse. So when I'm looking at TOA, I want the one that uses opposite and hypotenuse. Which one uses opposite and hypotenuse? Sine. When I have an angle, I use sine, cosine, or tangent to find a missing side. Does anybody remember what we use when we have the sides, but we want the angle? When we have the angle, we use sine, cosine, and tangent to find a missing side. When I have the sides, like I do here, I have the opposite and the hypotenuse. What can I use to find a missing angle? Did you have an idea? Yes, inverse sine. Sine with the little -1. Do you guys remember using that? Inverse sine. So we're going to take inverse sine of, and now here's where I need my ratio, my fraction. Sine uses which two sides again? Opposite and hypotenuse. Which one would go in the numerator? The 12. We put the opposite side in the numerator over what? Over 18, over the adjacent side. And that is going to be equal to my angle theta. So now I need to pop that into my calculator. To get to the inverse sine, inverse cosine, and inverse tangent, you have to push what buttons? You have to push the second button. You need to press the green second key and then the sine key. $41.810, so 41.81 degrees, yes. Part B says write an equation to find the value of x, then find x. So there's a couple things that we could do. Now that we know what theta is, I could use cosine or tangent to find x. Or I can use something a little bit more familiar, something that you guys have known about since before geometry, but we have used so much in geometry. Pythagorean theorem. We can do a squared plus b squared equals c squared. Now that's not the equation that I would solve, that's a formula. The equation that I'm going to solve has the numbers plugged into it. What thing has to go in for c? 18, because that's the hypotenuse. So I would have 18 squared in the place of c, and then what would go in for a and for b? 12 and x. So 12 squared plus x squared. And we are going to solve that now. What is 12 squared? 144 plus x squared equals, what is 18 squared? 324. So then we subtract 144 from both sides. What is 324 minus 144? 180. X squared equals 180. Now what? Square root. If you do it to one side, you've got to do it to the other side. The squared and square root cancel each other out over on the left. And what is the square root of 180? 13.416. I think the calculator at first tells you that it's 6 radical 5 if you're using one of my yellow calculators. And that comes out to be approximately 13.416. So I'm putting both answers down. If this is the written portion, you need to follow whatever the directions are for the written portion. But for the multiple choice section, if this was a multiple choice question, either of those might show up as possible answers. So I want you to be prepared and familiar with both of those. Yep. Typically on the written portion, I would probably want the decimal form, although I do know that because we talked about exact form, especially in this module here, it definitely can come up. Yep. What else would you guys like to see? 16, absolutely. Bobby is looking down from the top of a 150-foot vertical cliff and sees Sam down by the water's edge. If Bobby estimates the angle of depression to be 67 degrees down to Sam, what is the horizontal distance from Bobby to Sam? And this horizontal is really important. All right, so I'm going to draw a picture first. So we have a vertical cliff. And then apparently there's some water over here. One person is up on the cliff. One person is down by the water's edge. We know that the cliff is 150 feet up in the air. The cliff and the ground on the bottom are forming a right angle. And then we have this angle of depression. Something I want to caution you guys about. I see it every year because it's a very common misunderstanding. I know that Bobby is looking down at Sam like this. This is not the angle of depression. The angle of depression is how far down Bobby would have to tip his head. Normally, people walk around looking straight forward, right? So he would be looking like this, except he has tipped his gaze down like this to look at Sam. That is the 67 degrees. And that is exactly the same as the angle of elevation down here by Sam. So this would also be 67 degrees. Those are alternate interior angles. The ground and the line of sight would be parallel. And so those are alternate interior angles. And we want the horizontal distance from Bobby to Sam. I am not looking for this. That is the distance from Bobby to Sam, but that's not horizontal. Horizontal has to go like left to right. So when we say we're looking for the horizontal distance, we are looking for this distance right here. All right. So now we need to label up our sides. Hypotenuse, opposite, adjacent. Which side here is my hypotenuse? 67 is an angle. That's okay. Which side is the hypotenuse? The line of sight from Bobby to Sam, yes. This right here is the hypotenuse. Which line is confusing? This right here is an angle. This is showing movement. This is not a side. This is movement. This is a side of our triangle. Should we stand where Bobby is or where Sam is? We're going to stand where Sam is because this 67 degrees is inside my triangle. We always have to stand by the angle that is inside the triangle that is not a right angle. The problem with standing up here where Bobby is, we have 67 degrees up here, but this is not a triangle. This is a triangle, and we have to stand by that angle. So we're going to stand down here. We have our hypotenuse labeled. Which side is the opposite side? Which side? Give me a number or give me a location. Left, right, up, down, left. This is the opposite side. Bobby is standing up on top of that. That's why I didn't say anything about that. So he's standing up there. That's a single point. That would not be a side. So X has to be which side then? Adjacent. All right, so SOHCAHTOA. What are the two sides that we either want to know or that we already have? Which one? Adjacent and opposite. Opposite and adjacent. Which ones of these use both the opposite and the adjacent? Tangent. Over here. So we would have tangent of our angle, so tangent of 67 degrees. Equals what over what? 150 opposite over x, the adjacent. We want to solve this for x. X is part of a fraction, so we have to multiply both sides by x. Cancels out my denominator over there on the right. So on the left, I have x times the tangent of 67 degrees equals 150. What do I do now? Divide by tangent of 67 degrees, yes. So then we have x equals, and we do 150 divided by the tangent of 67, and we get what? 63 point, you said 671? 671. Should we put units with that? Feet, yes. Because we are given this right here, 150 feet for that vertical cliff. What else would you guys like to see? Yes.
For the inverse of the scientific is the only situation I would use that for when we're trying to find the angle?
Yes, the only situation where you use the inverse sine, inverse cosine, or inverse tangent is when you're looking for an angle. And specifically, you have to know two of the sides in order to do that. Yes. Number 18? Absolutely. Let's look at number 18. That's the very last one in this section, although it's not the last problem that we can look at today. It says, using special right triangle rules, answers must be in radical form. So when it says answers must be in radical form, your answer has no decimals. All right, so let's look at our special right triangle rules. For a 45, 45, 90 triangle, we had one rule. Hypotenuse equals leg times radical 2. And then for 30, 60, 90 triangles, we had two rules. With the 45, 45, 90s, two of the sides were the same. So I either know both sides and I'm looking for the hypotenuse, or I know the hypotenuse and I'm looking for both sides. With a 30, 60, 90, all three sides are different sizes. The hypotenuse is equal to 2 times the short leg. And the long leg is equal to the short leg times the square root of 3. All right. So looking at A here, is this a 45, 45, 90 or a 30, 60, 90? This is a 30, 60, 90. Here's 30, here's 90, so this angle up here has to be 60 degrees. Which of those sides is the hypotenuse? X. And then we have short leg and long leg. Which leg is the short leg? Radical 6. So Y has to be the long leg. The short leg will always be opposite the smallest angle. So opposite the 30-degree angle has to be your short leg. All right. So the hypotenuse is 2 times the short leg. X is my hypotenuse. So we have hypotenuse equals 2 times short leg. So that would be X equals 2 times the square root of 6. That is as simplified as we can get it. 2 radical 6. Y is my long leg. Long leg is equal to the short leg times radical 3. The long leg is Y. So Y is equal to radical 6 times radical 3. I don't want to stick this in my calculator and get a decimal back, so I need to be able to work with this as is. If I have two things that are both underneath a square root, we multiply them together and we leave them underneath the radical. What is 6 times 3? 18. So this would be the square root of 18. And now I have to see if I can simplify that square root of 18 at all. So I have to see if I can break that down. What things multiply to give you 18? 9 and 2. So that'd be the same as 9 times 2. Can we break down either of those numbers more, the 9 or the 2? Is there anything that goes into 9? 3. 3 times 3 gives me 9. So 3 times 3 times 2 gives me 18. So I still have radical 18 underneath my square root sign. I have a pair of 3's. So that means it can come out to the front. So 3. And then the 2 is still underneath the radical. So Y equals 3 radical 2. All right, part B. We want to find U and V. Since it's a 45, 45, 90, I know that because I see 45 here and 90 here. So this has to be a 45-degree angle down here. U and V are congruent. So these will be the same. With a 45, 45, 90, we don't have a short leg and a long leg. We just have leg because they're the same size. Hypotenuse equals leg times radical 2. The hypotenuse is 10 radical 2. I need to pick one of those legs to put in for L. Are you guys okay if we go with U? U times radical 2. I want U all alone, so I'm going to divide both sides by radical 2. It's going to cancel out over here on the right. On the left, I have a radical 2 in the numerator and a radical 2 in the denominator. Those are also going to cancel out. So I would have 10 equals U. So we have 10 for U and for V. Yes. If it doesn't cancel out, then you have to rationalize the denominator. So let me do an example down here. So if we had, say, 10 radical 2 over, I'm just going to make up something here, and we're going to say radical 5, like this. Then you would have to multiply the top and the bottom by the radical that's in the denominator. And so up on the top, I would have 10 times the square root of, I would have 2 times 5 underneath here, because those are both under the radical, over the square root of 5 squared. When we square a square root, those cancel each other out. So then I would have 10 square root of 10 over 5. And the last thing I could do is these two here can simplify. 10 over 5 would give me 2, so I would have 2 square root of 10. You're welcome. Yes? How did I know that U and V are congruent? Because it's a 45, 45, 90. On a 45, 45, 90, you have to have 2 congruent sides. Yep. Good question. All right, that is where I have to stop for today if I'm going to have time to pass back your tests. I will take questions tomorrow over the remainder of the packet. I need you guys to finish the packet out, modules 10 and 11. And then Monday and Tuesday, I will answer questions individually while you guys work on your cheat sheets.